Hello, I'm MC Toon. Welcome to Tuesday night. Tonight, I've got a special guest. I have Bob the Science Guy joining me tonight. Welcome, Bob.
Well, hi, MC. Thanks for having me, man.
I'm glad that you reached out to me. This was a good timing. I don't want to steal your thunder. I'll let you explain what we're here about and go over all the fun.
Well, one of the first things that I did in the flat Earth was I took an observation that was making the rounds on Mount San Jacinto from Point Dume in California, 123 miles away. And the flat earthers were just going absolutely ape crap about trying to show how this proved the Earth was flat. And of course, it's a perfect globe proof. And I showed that about 2 years ago. Well, apparently, some of the folks over there didn't get the memo. And I was on 24/7 before Indio booted me from the server and his life. And he was saying that he had done the definitive video on Mount San Jacinto. And that if I really wanted to learn something, maybe I should go look at that one. Well, I took his advice and I did. And I'll tell you, man, I'm here to eat string cheese and take names tonight. Let's go over it.
All right. Well, when you're ready, if you want to present, you can, or you can we can talk about it a little more. But I think it's important to note that Indio booted you from the 24/7 Flat Earth Discord server definitely for a good reason, right?
That's right. Absolutely. Because, I said, look, Indio, you're an idiot. Let's go ahead and take this mano a mano on MC Toon. And let's go ahead and justify your video there. And you and I can just have an adult talk about it. Unfortunately, I don't think he wants to come over on your channel.
Yeah, well,
you have the
Indio,
opportunity.
Yeah, the invitation's out there, Indio, but
yep.
I'll be sure to be watching my my Discord right there on my phone. But so far, nothing.
Yeah, no, nothing so far. He still has me blocked. And all of his videos, of course, have no comment on it, including this one. No comments are allowed. So
you wouldn't want to allow somebody to critique you.
Well, as you know, one of the things that I'm really interested in with a flat Earth is science denial. And I'm going to go ahead and go through Indio's video tonight. And that's it right there, Dr. Lee McIntyre, How to Talk to a Science Denier. And there are certain characteristics that are pretty common in the science denial community. One is belief in conspiracy theory, and the other is just outright poor scientific reasoning and an inordinate expectation of perfection from science. And we're going to see all of that in this. So without further ado, let me go ahead and pop over to that video, my man. How's that sound?
Sounds good.
So what we're going to do is I'm going to kind of go through this real quick. And then I'm going to stop it once in a while and just make a couple of comments. And then we're going to really zero in on his conclusions at the end. He's only got about a 12-minute video. We're not going to play all of it, but I'll play some snippets of it. So here we go. All right. You got the screen there, my man?
It's coming up. There it is.
All right. Excellent. So this is his video right here, and I'll put a link to this in the chat in a little bit. But y'all remember the J. Tolan Media 1, Behold the Flat Earth, the Mount San Jacinto infrared observation from Point Dume, which is about 123 miles or 195 kilometers from this mountain, San Jacinto. Do y'all see my cursor on there?
I do.
Okay, great. So we're in good shape. So what Indio wanted to try and do is come up with the ultimate last word on it. And to establish his credibility, he downloaded this image, a short video clip from a class on photometry. And basically, this is to establish him as a quote-unquote expert. The problem that these folks don't seem to understand is that some of us actually know this stuff and realize that they did not watch the video, much less understand it. So let's go ahead and see what he has to say about it. I'm thinking that we're up here at about 2 minutes. Here we go. So
cameras measure direction. Cameras have an optical axis, which generally corresponds with the center of a photo. Tilt affects how an image is projected onto the film or camera sensor. Tilt should be considered when making measurements. You can determine the tilt of a camera by finding the image center. You can find the center of a photo by marking 2 lines across each diagonal. The camera was tilted from horizontal when the image was captured. The intersection of the X is nearly as high as the peak of San Jacinto. What also need to be taken into account is occlusion.
Well, this is kind of a classic Phuket word thing, and that is that unless it's exactly in the center of the image, you can't make any measurements from it, which is nonsense. You know, I've demonstrated that a number of times myself. The camera doesn't really care where the image is in the where the subject is in the image. It's just like taking a picture of the star trails around the North Celestial Pole. You don't have to have the camera exactly centered on the North Celestial Pole to get a star trail. Polaris could be off to the side and the stars will just happily revolve about it. But let's go ahead and see what he's going to try and do. Now he's stating the obvious right here, and that is occlusion. So for example, if you have a big truck here, you're not going to see this little car next to it if you're looking from up here in the corner. This is pretty basic stuff, but he'll still screw it up. I have faith in him.
Occlusion is nothing more than obstruction of a background object by an object in the foreground. In order to know what the lowest possible features in the line of sight are, we need to consider occlusion. Now, each landmark will be listed in order of closest to observer location to furthest from observer location.
Now, I've gone over this image quite a bit. Now, he's got a few things marked on here. Some of them I'll address now, some of them I'll address a little bit later. But having gone over this image in detail, he didn't do too bad of a job identifying these landmarks, which is kind of a rarity in the flat Earth. There was some question about this Black Mountain because that's not listed as Black Mountain on Google Earth. Black Mountain is way off to the right here and 50 miles further. But if he's going to call this little thing here Black Mountain, we'll go ahead and go with it because I think I know what he's talking about. But let's go ahead and listen to his measurements and everything.
Accompany each landmark with information on the line of sight, elevation, distance, third-party image of the landmark, and the location of landmark in J. Tollins image. Also included will be an image of a representation of the landmark in an orthographic geometrical construction using both a 7/6 R ball and a flat surface.
Now, this is indeed Point Doom. This trail, which I followed on Google Earth, goes up to a parking area up here. Now, the parking area is at approximately 160 feet. Now, he's listing it at 150, and I'm not going to split hairs with him. That's not my style. Close enough.
Observer. Distance 0 miles. Elevation 150 feet equals 0.02 miles.
It's a pretty place.
Yeah.
So there's the parking lot up there.
Horizon. Distance 16.2 miles.
Now, this is kind of an interesting thing. Mike, do you have a calculator handy?
I do.
All right. What's the formula that they like to use for distance to the horizon? You know, the horizon can be no more than 1.22, what is it, times the
square root of the observer's height in feet.
All right, so let's go 1.22 times the square root of 150. What's that give us?
Oh my, yep, hold on. 150?
Yep.
Square root of 150 is 12.24.
Times 1.22?
That's 14.9.
Now, isn't that interesting? Because according to Nathan, on a sphere Earth, the horizon can be no further than 1.22 times the square root of the observer height in feet. Yet he's already admitting that the horizon is going to be 16 miles away, which, check my math there, Mike, is 16 greater than 14? I think it is.
Yes.
Okay. It's actually 16 and a half miles. But again, who's going to split hairs with a brilliant person like Indio?
Yeah.
Elevation 0 feet. Venice Fishing Pier. Distance 19 miles. Elevation 45 feet estimated. Marina del Rey. Distance 20 miles. Elevation mean sea level equals MSL.
Remember that. He said Marina del Rey is at 0 elevation, at mean sea level. That'll come in important later. Boy, I can almost see Marina Del Rey
Westchester
there.
Medical Plaza. Distance 23.7 miles. Elevation above MSL 130, building height 159 feet, total 289 feet equals 0.05 miles.
Okay, then he goes in Morningside Park and a couple of other
210 feet
things.
equals 0.04 miles.
All right, so good for him.
Elevation above MSL 1,700 and hill. Distance 61 miles.
This is San Juan
Elevation
Hill.
above MSL 1,782 feet equals 0.33 miles.
Okay. And he did it correctly identify San Juan Hill in his image. It's just over the horizon. All right, we get it there, Indio. Let's go. And that's San Juan Hill. You see how close it is down to the horizon? It's
Black
below
Mountain.
peak.
Distance 118 miles. Elevation above MSL 7,772 feet equals 1.47 miles.
There were 3 Black Mountains listed. I guess there's a 4th. And that is the correct location of Black Mountain, or what he's calling Black Mountain.
San Jacinto Peak. Distance 123 miles. Elevation above MSL 10,800 feet equals 2.04 miles.
And that is indeed Mount San Jacinto.
He left off the suspenseful music.
Yeah, I know. I was kind of upset about that. I was looking forward to that stuff. But let's just go over a couple of things that we've got so far. Now, just using Walter Bisselin's advanced Earth curve calculator, which I've used for years, you've used for years, it's verified itself many, many times.
Yeah.
Now, San Juan Hill at 61 miles is 1,782 feet high. And at 61 miles, 684 feet is hidden on the globe. Okay. Black Mountain at 7,772 feet has 5,707 feet hidden on the globe. So we do have a little bit out there. And San Jacinto is at 10,692 feet. And of that, 6,283 is going to be hidden. Now, that's with refraction. If you don't include refraction, 7,781 feet of San Jacinto will be missing. But let's go ahead and see how he calculates the numbers that he's going to use for these. We'll go ahead and hit that real quick.
Tarquis Peak. Distance 123 miles.
That's the one off
Elevation
to the
above
right.
MSL 8,846 feet equals 1.67 miles.
Yeah, that's the peak that's off to the right, and it doesn't really add anything to this, so I'm not going to bother with it. Basically, we're looking at line of sight from Point Doom.
Now we will take those data points and place them into a 2-scale geometric construction. Lines will originate at the observer. They will be placed so they intersect the top of each landmark. As demonstrated by the previously shown image, any object at a further distance and below the respective line will have those features obstructed from any possible view.
All right, so I'm pretty much in agreement with this so far. Obviously, if you have a mountain like right here, we've got Black Mountain. And you'll see the top of Black Mountain. You will not see anything behind Black Mountain. Now, mind you, Black Mountain is not quite a distance from San Jacinto. It's only about 3 or 4 miles in front of it. So there's not this huge slope that you're seeing. This mountain is actually way over here. But I think it makes common sense to everybody that you won't be able to see this part of the mountain because it's blocked by Black Mountain. but it's not going to change the height of the mountain, and it's not going to change where the horizon is going to be and where the cutoff on the horizon is going to be. So that's one fundamental flaw in scientific reasoning that he's made so far. But let's let him go ahead and make his flaw.
Using this method, we can determine what elevations should and should not be visible.
Now, why he's got 7/6R globe here and he's drawing flat lines on a flat surface, I don't know.
That's weird. Yeah.
Yeah. If you're gonna draw flat lines on a flat surface, you do it pretty much like Walter Bislin does, which is like this. Where'd he go? Right here. So you see, this is how you draw a curved surface.
Wait, I don't see it yet.
Oh, okay. Hang on. Let me change that on over for you. That'll just take a moment.
And over low elevation water, 7/6 is probably a pretty bad estimation.
Yeah, I would say so too.
I'd probably go with the U.S. Meteorological Society's a number of 0.33 instead of 0.17.
That's what I needed to do. Sorry about that. All right. So this is the way that you draw a curved surface that you're doing lines on. You don't start with a flat earth surface and then try and put the curves into your lines of sight. I mean, it gets confusing that way. That's the way you would do that. Instead, he chose to use a flat baseline and draw parallel lines everywhere, which is, well, silly. So we'll go ahead and get back to this then. My apologies. It takes a second. I've only got the one screen right here.
Oh,
so it just takes me a second to kind of get everything.
One screen. How do people live like that?
I don't know. It's the dark ages, man. So here we go.
Well, I mean, at least you moved up to Windows 3.1, Windows for Workgroups. So
yeah,
you got
right.
that going.
All right.
None of the Flurfs ever have even computers, hardly. So, I mean,
let's go ahead and get this one back up. Sorry, it's just taking a second to get this shared again.
Yep. All right, we see it now.
You do see it?
Yep.
You see his, correct? The 7/6R one?
Yeah, it's hidden, kind of snuck behind there.
There, you got it now?
Yep.
Come on. There we go. I'm going to try and minimize the switching back and forth because it kind of gets difficult with the one screen.
Yeah.
But you see, I guess he's trying to put in the 7/6R here, or he's trying to figure out what's occluded.
On flat Earth or he's got the curve down below.
Yeah, he's got 7/6R here, and it says sea level globe, and then these lines are coming up at an angle. So what he's trying to do is, I think confusing to even him. But in any event, let's get on over here and see what we have.
We'll now explain the numbers in the image. The vertical line is the line of...
Okay, so here we go. Here he's going to explain how he got these numbers on his image. Because this is the interesting
I will
part.
now explain the numbers in the image. The vertical line is the line of sight to the peak of San Jacinto.
That's this here.
The horizontal ticks align to the tops of each landmark used in the geometry
There's
construction.
Black Mountain.
The numbers indicate the number of feet that would be obstructed at the elevation and distance of San Jacinto. For the horizon to morning sun.
Did you notice what he just did? He said that this is the number of feet that would be obstructed at the level of San Jacinto on something that's 20 miles away. That's not really true. He's got that kind of messed up, but we're going to go ahead and continue on.
Hyde Park obstructs 580.8 feet of San Jacinto. From the top of Morningside Park to the top of San Juan Hill obstructs 422.4 feet of San Jacinto. From the top of San Juan Hill to the top of Black Mountain obstructs 686.4 feet of San Jacinto. This leaves 2,323.2 feet of San Jacinto unobstructed and visible according to the globe.
Now, if you total all of that up,
Yeah, you're around just over 3,000.
no,
Right?
you've got 2323 from San Jacinto itself is visible, and then you've got about another 10 or 15 or so that is obstructed by these objects in the foreground, San Juan Hill and Black Mountain. Now, the thing that I pointed out to him was the fact that the mountain is over 10,000 feet high, and you've accounted for about 3,000 feet.
Yeah.
Where's the other 7,000 feet, Indio? And then he blocked me. And that was the thing that really nailed it. The problem that you're running into, and this is the bad scientific reasoning that you see with these guys, is even his own numbers, which I might add are wrong, tell him that there's over 7,000 feet of missing mountain, but he can't connect the dots in his head that missing mountain's missing for a reason. He seems to think it's hidden behind San Juan Hill.
that small part.
Seriously?
How?
Does he think it's hidden behind Black Mountain? Just because it's hidden behind it doesn't mean it doesn't exist. You can go to the top of the peak and measure how much of that mountain's visible. And then you can tell from that exactly how much is missing. But, it was hard for me to believe that was his argument, but have a listen to it because he thinks he saved himself.
Something is missing though. Where is the eye level at San Jacinto? I will now measure that and add it to the image.
Sure you will.
The eye level is 1,953.6 feet visible above the horizon.
What? All right. You got to be able to at least set this problem up. On a flat Earth, your eye level from an observation height of 150 feet will be 150 feet. On a curved Earth, if you look at the curve falling away from you at 8 inches per mile squared, your eye level is going to be at 10,200 feet. Where he's coming up with this 1,900 feet, I've got no idea. I think he just pulled it out of his tail to try and make some of his other numbers make some sense, but he couldn't even do that. Have a listen.
And 316.8 feet visible above Black Mountain according to the globe.
You see where
Obviously,
he's got
there is a big problem with the globe geometry and the eye level.
You see where he's got globe eye level listed here? There's a large white feature here. And when you look at that in close-up, it kind of looks like it might have been a landslide at one time.
Yeah.
But it's kind of scarred with vertical lines in it. And I asked him, okay, well, what exactly is the level of your globe eye level there on the side of the mountain? What's the elevation where that line intersects San Jacinto? And he said it was like 7,900 feet. And I said, well, or 7,500. So that means there's about, 2,500 feet above it, right? And it's about that far down here into Los Angeles. So you've got about 5,000 feet of the mountain accounted for. Where's the other 5,000 feet?
Yeah.
That was the thing that really kind of got him. And he's really stuck on that. And, it's kind of confusing because you have no idea what he's trying to prove with this. All he's doing is demonstrating that the bottom of the mountain is hidden as would be predicted on the Earth curve calculator. That's the thing about flat earthers. They know so little about this stuff that they end up inadvertently disproving their own position and proving yours. And that's the case here.
These buildings are University Hall and Hannon Library. These are on the Loyola Marymount campus. Hannon Library sits at a 150 feet elevation. This puts the real-world eye level at this red line. This fact alone is completely inconsistent with the globe prediction. The globe model does not conform to the image even using the standard refraction model.
Nor would it. That's the flat Earth model, where you're saying eye level is at 150 feet because you're observing from 150 feet. On the globe model, with a curve going away from you, your eye level at the level of San Jacinto will be at over 10,200 feet. I don't think you can figure that out.
No.
And that is not the only problem. The horizon also shows that the image is inconsistent with the globe model. The globe predicts the horizon is 16 miles away. For the image, we can clearly see the Venice fishing pier 19 miles away. To the left, you can see a break in the shoreline. This is a breakwater that is also 19 miles away.
Now, let's go ahead and have a quick look at that one, because I think that that's important. I'm going to go ahead and share the advanced Earth curve calculator with you guys. And I do believe that's it right there. You got it?
Yep.
All right. I'm just going to make it a little bit bigger so y'all can see it really well. Now, we've got this in freedom units, miles and feet. So we're at an observation height of 150 feet. He's already admitted that. Marina del Rey is 19 miles away. All right. The target size he's got listed as 0, but I think we're gonna go ahead and we're gonna put in 30 feet just for laughs, and we're gonna hit standard refraction. How much is hidden? 3.56 feet. So if there's anything at Marina del Rey that's higher than 3.56 feet, you're gonna see it. Wouldn't you agree?
Yeah.
Let's go ahead and have a look at Marina del Rey. Remember how he mentioned the breakwater specifically?
Yes.
And the jetty?
Yep.
All right. So here is the jetty at Marina del Rey. Now, in case you may notice, on the right side of that, there's a guy in a white shirt fishing. Is that at sea level? No, he's a bit above it, yes. But what about the top of the jetty? How high is that? Is that 0 MSL? So this is the other thing that you'll see commonly with flat earthers is they'll falsify data like this.
Yeah.
He very clearly stated that Marina del Rey was at 0 feet MSL. And that thing there has got to be at least 30 feet high. And only the bottom 4 feet or so are blocked from 150-foot observation height at some 20 miles. So it's perfectly normal to see this. But you notice how he's presenting it as something that just doesn't make sense on the globe? It's because his followers won't bother looking. He put a picture up.
They use the reverse psychology is very important.
Mm-hmm.
The flat earth Papa Flurfs always say, do your own research. And that's actually reverse psychology. That's how they make sure they never do their own research.
Exactly. By saying do your own research, you give the implication that you're not concerned that they're going to find something different. And people that don't have the discerning minds that you'll see in normal folks will say, well, if he's that confident that I'm not going to find anything different, there's no sense in me looking.
Yeah.
And, this is a common, all you have to do is do a search for Marina del Rey jetty and then look at the pictures. That thing's huge. This is on the open Pacific Ocean, and there are $1 million yachts in Marina del Rey. You don't think they're going to protect them with a manly seawall? I don't think so. All right, so you should have that again.
Okay.
So we've gone ahead and gone through Walter Bislin's advanced Earth curve calculator. Let's go back over and listen to this guy for a while. Look at this jetty that he put up. You think he's claiming that that's the jetty at Marina del Rey?
That's not it.
No, it's not it. Not to mention the fact that that's still almost 10 feet high. You can see some guys out here,
Yeah.
some people standing next to it. But that thing there is between 8 and 10 feet high. You'd be able to see that one too. That's not abnormal at all. But this is another example of misleading in the video to try and make their point. This is one of the reasons that I go after these guys, is that I really hate people playing other people for fools. That's a good sized fishing pier too.
Yeah.
You ever been on one like that?
You can also observe
Yeah.
the same at the end of Marina del Rey. Marina del Rey is 20 miles away from the observer. The water's surface is clearly visible at a further distance than left and right shorelines. If the globe model were correct, it would be impossible to see the water's surface beyond its predicted horizon.
Now, this is the other thing. He's claiming that they're seeing the water surface beyond the horizon. All right. But he's not showing how that's happening. What he's seeing is the water surface, and he's seeing the jetty on either side. And I guess that's what he's calling it. I don't think he did very good research on this, is what I'm saying.
I will now explain the numbers in the flat Earth image. The vertical line is the line of sight to the peak of San Jacinto. The horizontal ticks align to the tops of each landmark used in the geometry construction.
And those are
The
correct.
numbers indicate the number of feet that would be obstructed at the elevation and distance of San Jacinto. For the horizon to Morningside Park obstructs 586.08 feet of San Jacinto. From the top of Morningside Park to the top of San Juan Hill obstructs 2,835 feet of San Jacinto. From the top of San Juan Hill to the top of Black Mountain obstructs 4,593.6 feet of San Jacinto. This leaves 2,787.84 feet of San Jacinto visible above Black Mountain.
Now notice that he's saying that this distance is 2787, but he's saying that this distance is 4,500 plus 2,900.
That's less.
Yeah.
A lot. Oh my gosh. It's not even the same vertical height, and he's saying it's
No. If you look at
8,000
this-
feet.
Let's be really generous. This is actually a little lower than midway, but let's just, for the sake of argument, say this is midway. So you'd have 2787 up here, and you would have 2787 down to here.
Yeah.
All right. That's not 10,000. There's missing mountain here.
It's just blatant.
It's blatant. And the problem that you run into is, first, flat earthers don't watch debunking videos. Ranty confirmed that to us. So they don't know about this stuff. They ban us from their servers, so we can't tell them about this stuff. And all they do when we do manage to get in and present something is they try and come up with a silly objection to it. But there it is, clear as day. I think everybody in the audience can see that very clearly.
Wow.
We're just about done with him, but then I'm going to go ahead and I'm going to show you how to do it right.
A simple analysis of this image indicates that the scales are distorted between the top and bottoms of the mountain.
He even acknowledges
Either the
that they're
elevations
wrong.
above Black Mountain are stretched, or the elevations below Black Mountain are compressed.
So what he did was he acknowledged the fact it doesn't work, and he invented an effect.
Yeah.
Cause that.
This phenomena exists using the globe numbers as well, though there is a smaller distortion of scale. This is due to the globe's standard refraction model being included, whereas the flat Earth construction has no account for refraction. A plausible explanation is the fact refraction is unequal on an upward slope versus a downward slope. In this,
Let's just go ahead and think about this for a second. Now, he's really smart, so he went out and he talked, he watched a video on photometry. However, and he read something on surveying. However, notice that the refraction, you get the illusion that the object is higher on this end, on the upslope end. And you get the illusion that the object is higher on the downslope end. On both ends, the object appears higher than it actually is.
That doesn't seem right. Because that requires pretty unusual
that's right.
circumstances.
Well, what happens with standard refraction is that the light bends downward into the denser medium.
Yeah.
And as a result, things that are lower appear to your eye to be higher because your eye just makes straight lines. It doesn't make the curve at the end.
Yeah.
All right. So the problem is even though, I haven't checked this myself, although it does kind of make sense to me. You are going to have refraction on both ends. It may be a little bit different because you're going into a less dense atmosphere or down into more dense atmosphere. But the bottom line is refraction causes objects to go higher, to appear higher than they actually are in both cases.
To appear
which is
higher, yeah.
Exact opposite of his argument. That is the exact opposite of what you would try and argue as a flat earther, that somehow refraction is making the object appear to be lower. I don't think he gets that.
In this case, the upward slope to the tops of mountains is greater than the lower elevations. In consequence of this, the direction in which light reaches the camera sensor will come from a higher angle as a function of height relative to the camera. In surveying, this is observed and called unequal refraction error.
Okay.
You can read more about it in an empirical assessment of refraction error in leveling as a function.
As if he's actually read that.
Hold on.
He's putting it up. He's putting it up to make himself appear as an expert.
Yeah. I'm going to go read it.
Yep, I know. That's why I put it up. I knew you'd read it. And it saves me the trouble of reading it. You read the book for me too.
Which book?
How to Talk to Science Deniers.
Oh, yeah.
Well, unfortunately, we actually read both. We read that at the same time. I'd love to get him on your show sometime.
I emailed him, but he didn't answer. So, all right, I typed it in. I have it. I'll find it. All right, you can keep going.
Let's see if we can find a phone number on him, because I think that he would be epic on your show.
I can get a phone number on him.
Yeah. All right.
Function survey order Environment Bulletin 2115 by the USGS. A full treatment of terrestrial refraction will be in a follow-up video. Thanks for watching.
All right. Was that fun, Mike?
I had fun.
Let's go see if we can do it right this time.
He kind of messed up himself.
Yeah, he kind of did, didn't he? Now, let's go ahead and do this in two different sets. The first set, I'm going to go ahead and I'm going to share a screen for you. And I'm going to share Google Earth. All right. Let's get that over here. Now, can you see Google Earth okay?
Yep.
All right, so this is Mount San Jacinto. And if you want to back it up, I got to move these out of the way. But if you want to back it up, okay, Point Dumais is out there. All right. And what we're looking at right now is we're looking at the line of sight to Mount San Jacinto. Oh, by the way, that's San Juan Hill right in there. Well, we're going to go on out here. We're going to have a look at Mount San Jacinto. And I just did a couple of quick things on this. Now, first of all, right, so here's the line of sight going to the top of Mount San Jacinto, and there's the peak. Right here, can you see that little red hashtag right there?
Yeah.
Right above my... Okay.
It's hard to see. It's a little small.
How about now?
A little better, yeah.
Yeah, right here is the top of Black Mountain. Now, these two lines right here, this is on Black Mountain, and this is on Mount San Jacinto. This is how much, that is the limit of the hidden height on those two mountains, according to Walter Bisslin's Advanced Earth Curve Calculator, utilizing standard refraction. So we should not see anything below these lines on a sphere Earth. And as you can see, there's an awful lot of stuff here. There's all these mountains. We've got towns. You know, we've got a lot of stuff going out here. I think that's Marina del Rey right there, actually.
Yeah, it looks like.
Yeah, I don't know. I've only been to California twice, and I don't hang out in marinas. But in any event, so what I did was I went ahead and I carefully measured those things out. And we're going to go ahead and stop this one here. We're going to share a slightly different screen. And that is going to be... Well, I don't see... So right here, what I did was I just went ahead and I took a little, you getting that one there?
Yep.
Okay, so what I did was I just went ahead and I took an image off of Google Earth. You see the hashtag at the top of Black Mountain there, and then you see the longer hashtag below it and the one off to the right.
Yeah.
That's the globe Earth limit. Now, let's bring this up. I'm going to stop sharing that one, and I'm going to go ahead and I'm going to share Photoshop for you. And there's Photoshop. You know what I'm doing, don't you? Now, do you see two images here?
Yep.
The bottom one is the image that I took off of Google Earth. And you see the hashtags?
Yeah.
Top of Black Mountain and the limit of the horizon on the globe Earth. And this is his image from his presentation. Now, you have to line these up and scale them properly. And as you can see, here's the peak, there's the peak, here's the side peak, and the side peak. The only reason I use that side peak at all is it's a convenient landmark. So I'm going to go ahead and I'm going to go on over here, and I'm going to do something I'm going to decrease the opacity of it. All right. So now what we're going to do is we're going to bring this right on up like so. And we're going to match up those mountains. Now, would you agree that's a pretty good map?
Pretty nice, yeah.
Now, the angle is slightly different, which is why you see a little bit of the mountain in the back here versus mine. Can you identify where those hashtags are?
They're about
Let me see if I can help. Let me help you a little bit. You see the hashtag right there?
Yes. Well, that lines up pretty nice.
And how about the other one?
Yep.
All right, right there.
Yeah.
All right, so that's really all that we need to do. The amount of San Jacinto that we see from Point Doom is exactly what we expect to see on the globe Earth. Now, I drew those lines not by superimposing these things. I drew them on Google Earth based on the elevation on the side of the mountain. And then I came down and I scaled it so that they lined up with each other. And that's exact. Now, the final thing that I want to show you is something from the original video that I did, which I think you're going to enjoy, because this is a video from another. This is going to be a video from another provider. No, provider. I don't mean provider.
A content creator?
Content creator. Yeah, I'm a provider. Let me go ahead. Oh, rats. You know what I did? I think I shut that off.
Somebody else's video on YouTube, right?
Yep. Well, it's my video, but I used part of somebody else's video.
Ah, okay.
Let me go ahead and see whether or not maybe that's in my history. Maybe I'll luck out and it's in my history. That's it right there. Ah, the gods are with me.
It looks like.
All right. So this is a guy that
I ran
into a while ago. And, you know, his name is OK Raylos.
Yeah, we can't see it yet.
Ah, got to share it.
Yep. Matthew Rain says you are a wonderful provider.
Actually, I am. I'm getting to the point right now. I'm kind of semi-retired. I mostly work with veterans, trying to help them with their benefits.
Oh, that's nice.
And it's very rewarding because, you know, a lot of these guys have really kind of been screwed over. Kind of screwed over, and it really just kind of bothers me a bit. Oh, now it shows up.
People are wondering if Indio sounds just like that voice on Discord.
Well, he's using a robotic voice right now. Why? I don't know.
Does he have a real voice?
I don't know. I can't remember hearing him talk. But let me see if I can get this. I wonder why that's not It's not showing for some reason. Because there it is.
I don't. Yeah, you're not sharing anything to me right now. Oh, there
No,
it is.
it's
Okay.
yeah, it's not
Okay.
letting me share.
I see. I see the. Yeah, I saw a video there.
I think this is it right here. Okay, you got it now?
Yes, that video of.
All right.
Yep.
This is okay. This is okay. Raylos is got all of the topographic data from California, and it's 3D modeled exactly. And I'm gonna let him go ahead and do this real quick because he just does an elegant job of it.
When I use a flat Earth model. So again, this is the view, the virtual view of the mountain using a round Earth model, using a globe with a radius of 6,378.1 kilometers. And now I'm going to slowly change to a flat Earth model, and then you can see what the differences are. And whoa, okay, that's amazing. That is a huge mountain.
Notice all of the detail that you're getting in those towns that are at the base of the mountain.
Yeah.
You see how different this is?
And you can see that by just changing this back and forth, we are suddenly seeing about approximately 2,400 meters more of that mountain as if we were using a curved Earth model. So just to be entirely certain about this, this is a rendering that matches an actual photograph which is based on a round globe. And this would be what that photograph should have looked like using a flat Earth model.
Well, I don't know about you guys, but let's go ahead and just, one of the things that he did just before this is he actually took Jay Tolan's image and held it up against it.
They don't like having their stuff analyzed.
Was the shape of the mountain line up pretty perfectly. I would say down to the pixel. So that's fantastic. I forgot to mention something, and that is that this viewer program here can use both a flat Earth model and a round Earth model. And we were doing this whole thing in round Earth mode. So,
and that, my friend,
Ah.
is how you eat string cheese and drinks flat Earth tears.
So,
because that's the way I roll there, Mike.
Who was that other guy? You said?
Okay, Raylos.
Okay, Raylos.
I'm going to go ahead. I'll stick his. What if you look on my channel? The video is on Bob the Science Guy, and it's can Jay Tolan identify landmarks?
The answer to that is no.
Hell no. I'll tell you something. He's sitting there. He flew over my house and claimed he could see Hudson Bay from my house.
Yeah.
I could practically see my backyard from that thing. I mean, you can clearly see Saginaw Bay. I know all the landmarks. I know where Alpena is and what it looks like from the air. I spent years training how to do search and rescue from the air. And the bottom line is I can identify stuff from the air. He can't. He is absolutely clueless.
Yeah.
The thing that he was calling Hudson Bay was actually a cloud layer. And, the farthest thing that you could see on that image was 215 miles away. It was an island in northern Georgian Bay. And that, by the way, is exactly what should have been the limit of your vision from 35,000 feet.
Yeah.
Technically, you should have been able to see as much as 235, but that last 20 miles was a bit rough. The only thing I could identify was 215. I did my best, man.
Yeah, they at that distance, it's pretty difficult to identify features that aren't very vertical.
Well, you can get an island. What I did was I got an island.
It sticks out.
It stuck out, and that's the only thing that I could identify. And it was 215 miles away measured. I could actually figure out exactly where the plane was at the time.
Oh yeah,
simply by simple triangulation. But that's what I wanted to go over tonight. I'm sorry Indio wasn't here to explain how he came up with that derp. I would have really loved it, but it was probably in his best interest not to come in because I might have gotten mean with them.
It's probably one of the wisest things he's done in his life.
Yes.
Yeah.
Yeah.
I mean, when flat earthers run away from a debate challenge, I'm like, that probably was a good choice.
Well, it's one of the reasons they call me the smiling assassin.
Yeah.
All right. Well, you have anything else, or does anybody in the audience have any questions?
Well, hey, anybody, if there's questions, we did have we had two things came in. We had the Caucasian Sensation was wondering if I would moderate a rematch between himself and FTFE on the topic of weed. That they did back in December, I think.
I'd get in on that.
Yeah. That's a good a topic that
I actually had to write a letter to a VA administrative judge today about cannabis and the use of cannabis by a veteran in Minnesota, I might add.
It's not quite here so easy.
I saw they had a card. I
don't know what that means.
On the Department of Public Health, they do have a license application there.
Oh.
Or some licensure information there. But in any event, not my state.
Yep. And then the Sun Express says moon. Whatever that means. Any other, tag me just in the chat, just tag my name. So,
well, the moon is actually very interesting because we have a clock in the sky. The stars give us the month, the moon gives us the day, and the sun gives us the hour.
Yeah.
Do you know how to read them like you would learn on Shamrock Banks Observatory, my astronomy channel? You'll never get lost. If you can see the stars, you'll never be lost, man.
Well, the Flurfs would, because it was February that I put out the $10,000 challenge. It's now November.
And unlike DITRH or whatever he is, you actually have the money in escrow.
I do, and I have independent judging.
Yep.
And clear. This is what they never have: clear, objectively measurable criteria.
Well,
right.
I've made it clear to DITRH when I offered to meet his challenge that I told him that I would meet his challenge and present my evidence if three things occurred. Number one, we're going to sign a contract, a legally binding contract. Number two, you're going to put the money in escrow, your 3 Bitcoin. It's going in escrow. And number three, we're doing independent arbitration by experts. And, if my evidence is good enough for the chair of the physics department at Central Michigan University, I win the 3 Bitcoins. Or if my evidence is good enough in a court of law. But you have to have...
He'll never do it. No.
You have to have a written contract that specifically outlines the requirements and is binding on you to pay me. And you have to have the money in escrow. And if you do that, I have a new telescope.
Yeah. So we've got some questions. Borg Emporia says, what's the best way to debate a Flurf?
Don't. It's, take the advice that A.T. Young, the refraction guru that they all like to talk about.
Yeah.
Dr. A.T. Young. I told him one of the things that I do for a hobby is that I debunk science denial and flat earthers. And his thing was, they're all idiots, get a new hobby. So I still do it for fun once in a while because I learn from this stuff.
Yeah. And I think it's important though.
Yeah.
Because in 2015, 2016, they were unchallenged.
Yeah.
Nobody was out there challenging them, and they convinced a lot of non-critical thinkers that now are the leaders of the Flurf movement. So I think you have to. Yeah.
Well, it's good for two things. First of all, you have people that are not science oriented, and there's nothing wrong with being an art major.
Yeah.
But the bottom line is, if you don't know better, the way they phrase their stuff and the scripts that they use almost makes sense. All right. You need to have a voice of reason that will sit down and say, well, no, here's what he's doing, and here's why he's doing it. And here's why it's wrong. And here's the right way to do it. The other thing that's cool about it is that it got me interested in it again, because what they tend to prey on is, you get some high school kid that comes into 24/7 and, they know the Earth is a globe. But 5 years ago, could you tell me precisely how to determine it was the Earth rotating and not the sky? Could you precisely tell me how to determine the distance from the Earth to the sun? These are things that even people that have technical backgrounds like you and I, we don't think about that sort of stuff because it never really came up. How do you do a transit of Venus, and what's the mathematics behind it? And what did Aristarchus do? And why is it that, the Earth is 3.6 times the diameter of the moon, and the moon is 30 point something Earth diameters from us? So if we know the distance, they often like to talk about radius. How do you figure out what the radius is? I gave them a test over on Geo server months ago. And I said, tell me 3 different ways that you can find the radius of the Earth. Or mainstream science claims that you can do it. And they said, well, Eratosthenes and Alberoni. Okay, and the third? And they had no damn idea.
Yeah.
All right. There's a lot of different ways that you can accurately get the radius of the Earth. All right. For example, Aristarchus worked it out 2,300 years ago, and I just gave it to you. The Earth is 3.6 times the diameter of the moon. If you know the diameter of the moon, you know the diameter of the Earth. We know the distance to the moon via Project Diana. We bounced radar off of it in 1946, and we've been getting consistent results since. So we know it's about 240,000 miles away. We know that the moon is half a degree in angular size. We can do the math and come up with the diameter of the moon. Multiply that by 3.6, you got the diameter of the Earth. If you know the distance to the moon, 30, divide it by 30, you got the diameter of the Earth. If you know the orbital period of the International Space Station, which I've personally confirmed using software-defined radio and the Doppler effect, you know that that's a 92-minute orbit. You know how high the radius of that orbit from the center of the Earth, and you know it's 400 kilometers above the surface of the Earth. All you have to do is take the orbit of the ISS, subtract 400 from it, and you have the radius of the Earth. And finally, all you have to do is drive between 2 cities that have known coordinates and use the Haversine formula and solve for the radius. You already know the distance, which is what you normally use the Haversine for. You just reverse it around and solve for the radius. Guess what? They all come back to the same number. And that's called scientific concordance, and that itself is a proof of the radius of the Earth.
Yeah.
So
when multiple different methods net the same result, then
itself is proof.
It increases your confidence in the result. So
Yep.
All right. The Rocket Couch says, has a question. How many string cheese is the moon?
At least 6.
Fly Up USA says, a triangle size 1, 1, and 1. What is the majorcation?
I've got no idea what he's talking about.
Trey Hutchinson came on here. He was reading an article on Antarctica, and he read, sodium was the majorcation.
Vacation.
What?
That's the type of cooking they do down in Louisiana, right? It's
yes. And then of course chlorine was the major anion. Like, hold on a second. Do you mean cation and anion? No.
Oh, I'm not. If they screw up you notice that I didn't really screw up. I didn't really screw with Indio on his pronunciation of San Jacinto.
Yeah. Well, the point is he was claiming to be a mechanical engineer.
Indio?
No. Trey Hutchinson.
Oh.
A mechanical engineer has at least 1 year of college level chemistry. And so when I asked him, what's that word? I said, what's the word? And then I said, no, it's cation. And then he rejected my answer. Like, you've never taken a college level chemistry class.
Yeah.
So Dave Fierce
It
is.
amazes me when people that claim to be engineers are flat earthers.
Oh, I know. Dave Fierce says greetings from Eski, Bob.
Eski.
I don't know where Eski
That's
is.
the moonlight. Escanaba in the moonlight. That's Escanaba in the UP.
Okay. Let's see. Timbo Turtle.
Clinics up there.
I've seen what they say change in the time I've been following you, but you can never win. Seen what they say change in the time. I don't know. Sorry, I didn't get the context of that. All right. So I'm going to be watching the launch of the
At
rocket.
1 o'clock, I think it is, isn't it?
It's 1 year time. It's just after midnight here. Assuming they launch at the beginning of the window. Hopefully, that'd be nice. So I'm starting my live stream about 15 minutes before midnight, my time. So
you're going to live stream it?
yes.
I'll stop by and visit.
Yeah. So now I saw your video. You have an observatory.
Yes.
That you're setting up.
I have Shamrock Banks Observatory, which is actually one of my channels here. It is an official observatory for the Minor Planet Center at Harvard. I study asteroids, comets, and near-Earth objects. I've got a variety of telescopes out there, and I'm starting 3 new playlists on the Shamrock Bank Observatory. I'm doing a Learn the Sky, where I'm going to go over all 88 constellations, including collabs with folks down in Australia, so we can get the southern ones. I am going to be taking a vacation down south a little bit later on in the year, and I may, if the gods are with me, just before dawn, catch a glimpse of the Southern Cross. And the other thing that I'm going to do is the other playlist is that I'm going to go over what I've learned in amateur astronomy over the last 3 years. Here are my mistakes. Don't you make them. Here's the better way of doing it. And then I'm going to do a technical astronomy for computer-assisted astronomy using the software, the computers, automatic focusers, things like that. So it's going to be kind of new. We got a little fundraiser going for it right now. We're trying to get it. I built a deck for it, and I've got a pier, but what I really need is a dome. So hopefully with the help of my supporters, my Patreons and PayPal donations and such, I can raise the rest of the money for the dome. We've got about $2,000 banked on it already for the total cost of about $4. And got a little link for a PayPal in case anybody wants to support it a little bit.
I put it in the chat there. I'll also put it in the description for you.
Oh,
so
thanks.
That'd be good. So that that observatory tour that you did was on your not your Bob the Science Guy channel, but
on Shamrock Banks Observatory.
Yeah, all right. So I will have to grab that.
And
can you send me the link to that channel?
Yeah, I'll find it for you.
Okay.
But yeah, I went over the telescopes and I went over the ham radio equipment. I'm a ham radio operator. I got my general license last June. And before too long, I would very much like to do what's called an Earth, Moon, Earth bounce and be able to personally verify the distance from my backyard to the moon. An Earth, Moon, Earth bounce, you send a signal to the moon and receive the signal back from it. And the delay will, and the speed of light will tell you the distance it travels. And with any luck at all, it's going to come out to about 2.4 seconds is what most of them seem to be doing. And that would correspond to a distance of 250,000 miles.
And what are the interesting attempts that flat earthers have had to hand wave away the EME?
The what?
Earth, Moon, Earth bounce.
Oh yeah, I'm sorry. The thing that I just talked about. Yeah. You know, when you're a boomer like me, you have that short attention span sometimes, but I'm still a lot smarter than any flurf. Yeah, the EME. Yeah, they hand wave it away. Why? I don't know. I think it has to do with them claiming, well, we don't know the one-way speed of light. Well, we don't need to. By convention, it's the two-way speed of light we use, and it works every time. So you can raise all of your silly objections The other one is that, here's a question for you, Mike. If you have two lines that cross, they form an angle, right?
Yes.
Does that angle, is it in any way, shape, or form dependent on how long either of those lines are?
Nope.
Okay. So if I've got a vertical line and I've got a horizontal line at a 90-degree angle to it, does it matter how long that horizontal line is?
Nope.
Nope. They're trying to tell me that because I used an auto level for that, I can't measure the curve of the Earth being 2 inches over half a mile, which I might add is exactly 8 inches per mile squared, which is what I got. I physically measured the curve of the Earth over the lake in my backyard, which is half a mile long, using the water as my reference level.
Using the water as a water level.
Exactly.
Imagine that, yeah.
2,500 feet long. And guess what? Half a mile, 2 inches, which is 1/2 squared times 8. And I asked them about that the other day. They couldn't tell me what 1/2 squared was. For those of you that are listening that are of the flat earth persuasion, if you multiply 1/2 by 1/2, you get 1/4. 1/4 times 8 is 2. Just trying to help out because I'm just that sort of helpful guy.
It didn't even occur to me that they would have trouble.
They can't multiply fractions.
No.
That's the thing that amazed me. I mean, something that we learn in the 6th grade, they can't do.
Oh my God. I mean, we homeschool. I help my kids. I was just today looking at some fractions on multiplication and division of fractions.
If it was differential equations or calculus, or even geometry, I would think that, okay, well, hey, it's understandable you don't know that. But multiplying 1/2 by 1/2 mystified them.
Albino Bad Guy says that you should say you're doing a fundraiser to see a dome, and the flat earthers will fund it.
Well, they're begging for people on 24/7 right now. And I told them I'd be happy to come on if, number one, they unbanned me, and two, they paid $50 towards the dome for the tutoring fee.
Oh, yeah.
And for some reason, they don't seem to want to bring me in. I got the idea from Mitchell from Australia, who charges $150. I figured, well, hell, I'm not as nice as he is, so 50 is probably enough for me. But they don't want to donate to the dome.
I don't know.
We were looking at satellites the other day. Watching satellites in space the other day.
Yeah.
That was kind of cool. Guess what? They're right where NASA says they are.
Amazing.
Amazing, isn't it?
And what's their explanation? Nothing. So
projections. How do you know they're not projections? Is what was in your chat. And I said, well, because of these 6 reasons. We launched them. We have the orbital elements of them. They're right where they're supposed to be, and we can find them. Yeah. That's proof enough.
Yeah, and where's your evidence that they're projections? Oh, they could be. They could be.
Well, they don't seem to understand the difference between, well, we could do it and we did do it. There's a lot of things we can do. There's not a lot. There's fewer that we should do, and there's fewer still that we have done.
Yep. All right. Well, Bob. Oh, I've got one more here. Judy Bassett, who was one of your
She is my main Patreon for the observatory.
Yeah, there you go. Says for 10 euros. I don't know how Judy is paying in euros, being she's in the US, but Judy says, Flat Earth Tears, extra salty, thanks, MC Toon. So
indeed.
We will be watching the Flat Earth Tears flow. Hopefully with the launch here in just over 3 hours. So
yep.
All right. Well, anything else you'd like to add before we pop out?
Nope, not unless you want to stick that PayPal up again just for good luck.
I'll do that. It's in the description. And
this is little Missy here.
Oh, there. Somebody did Missy just show up?
Missy shows up. Now Otis is my astronomy cat. He is a pain in the butt. What he'll do is, I set the computer up out at the telescope, and I run it from in here because Michigan's cold. We got our first snow today. But he likes that glowing keyboard, and it's a little warm. So what he'll do is he'll sneak out there, and then he'll lay down on the keyboard, and he'll slew the telescope. And I think he signed me up for 6 years in the Navy the other day, which kind of irritated me because I just as soon go back in the Army. But oh well.
Yeah. All right. Well, we've got Charlie Welch says Artemis ain't going leak being addressed. Ooh, do you have a link for that, Charlie?
Charlie's the one that works with telescopes and was down in Antarctica, wasn't he?
Maybe Charlie does, but Geistview is definitely
Geist views, yeah. But I think
matches
Charlie,
that description.
I think Charlie, well, yeah, and there's a couple of them that have been down there that I know, but I think Charlie actually works for a telescope company.
Okay. All right, I'm looking.
Thank you. Move.
My kid was going to hand off my 2 cats to show off, but it didn't happen. So, all right, I'm looking right now.
Otis brought that one home when she was a kitten. She crawled up in the engine compartment of my truck and started yelling. So I obviously had to take it out. And then, of course, I had a kitten in my hand, which meant that it had to come in the house and get fed and get cleaned up. And then, and then we had 2 cats. How the hell that happened, I don't know. I don't even like cats. I'm a dog guy.
I like Otis, dogs, and we have dog. 2 cats, no dogs.
Yep. Well, Otis thinks he's a dog. He's got, cat hardware and dog software. He sits, follows commands. Missy is basically just a skitty kitty. She's just pure cat.
All right, I'm looking. Charlie, did you link it? Anyway, well, if it doesn't happen, then I won't be live streaming it if they cancel it. But if unless it
doesn't happen, do it again.
Yeah, I mean that's NASA's. That's part of the frustration with NASA is that they're not good at rapid development like SpaceX does. They change things quickly, and so anyway.
Well, they got to wait for the window. I don't know when the next one is. If they don't launch this time, they'll launch the next one. I just want to get there before the damn Chinese do. That's all I care about. Just because America.
All right. Well, people, thank you very much for stopping by. Thank you, Bob, for this. And Indio, someday you might dig deep.
Grow a pair? Dig deep and grow a pair, man.
All right. We'll see.
Thanks for having me.
Thanks
for having me, Lindsay.
All right. Bye.